can we tell whether a proportion is true or not? Well, one way that we can know that a proportion is true is by simplifying each ratio as much as possible. So let's suppose, for example, we asked, is 6 over 9 equal to 8 over 12? Well, 6 over 9, these numbers have a common factor of 3. Canceling that out, we get 2 over 3. 8 over 12, these two numbers have a common factor of 4. Canceling that out, again we get 2 over 3. So, because each of these ratios is equal to 2/3, they are equal to each other. So yes. Alright, that's all well and good for this proportion. What if I asked, is 7 1/3 over 18.4 equal to 5.3 over 12.5? Do you want to simplify that? I don't want to simplify that. Let's see if we can find another method. In order to find another method, I want to take a look again at my original proportion. I said that 6 over 9 was equal to 8 over 12. And the basis on which I said that is this. 6 over 9 is 2 times 3 over 3 times 3. On the other hand, 8 over 12 is 2 times 4 over 3 times 4. And now, looking at those factors, I want you to look at what happens when I multiply these two numbers together and when I multiply those two numbers together. When I multiply pair number 1, I get 3 times 3 times 2 times 4. When I multiply the other pair, I get 2 times 3 times 3 times 4. And notice, these are the same 4 numbers, just shuffled around. Since order doesn't matter in multiplication, it's going to have to be that these are equal, right? And in fact, when I do this multiplication, I'll get 9 times 8 is 72. And when I do this multiplication, I'll get 6 times 12 is also 72. They are equal. This process, multiplying the first numerator by the second denominator, the first denominator times the second numerator, this is called cross-multiplying. The process is called cross-multiplication, and these products, and we can use this process, cross-multiplication, calculating the cross products and looking at them to decide whether or not a proportion is true. In particular, a proportion is true if and only if the cross products are equal. Why? Well, in any true proportion, we'll have the simplified ratio with the numerator and denominator multiplied by the same thing for the first ratio, same simplified ratio with the numerator and denominator multiplied by the same thing for the second ratio. The numbers might not be this nice in every proportion, but we'll always have these 4 numbers appearing assorted in this way. So to decide then whether two proportions are equal, we can compute the cross products and see. So let's look at that unpleasant proportion we had before again. Is 7 1/3 over 18.4 equal to 15.3 over 12.5? Well, we'll compute the cross products and we'll look at them and we'll see, are they equal? So the first cross product, we have 7 1/3 times 12 1/2. In order to multiply these, we need to write them as improper fractions. 7 times 3 is 21, plus 1 is 22. 2 times 12 is 24, plus 1 is 25. And now we'll multiply the numerators, multiply the denominators, cancel any common factors we find. I see a 2 in common. Now we're left to multiply 25 times 11. I get 275. So this is 275 thirds, which, after long division, 3 goes into 27 9 times. 3 goes into 5 once. 1 times 3 is 3. 2 is left over. So this is 91 2/3. The other cross product, I'll have 18.4 times 5.3. Let's just write that out. Ignore the decimal points and multiply. 3 times 4 is 12. 3 times 8 is 24, 25. 3 times 1 is 3, 4, 5. 5 times 4 is 20. 5 times 8 is 40, 1, 2. 5 times 1 is 5, plus 4 is 9. 1 2 digits to the right of the decimal point, 1 2 digits to the right of the decimal point. I get 97.52. So 91 2/3 is definitely not equal to 97.52. This proportion is false. And we were able to know that without ever simplifying either one of these ratios, which makes us happy. Let me give you one of these to try. Decide whether the proportion 2 1/3 over 12 equals 5 over 25 5/7 is true, using the cross products. Pause the video and try this now. All right, so we'll have two cross products. I really recommend that when you go to cross multiply, you actually circle the cross products like this, just because it helps you keep track of what you're doing. All right, I'm going to do the green one first because it looks easy. 12 times 5, 5 times 2 is 10, 5 times 1 is 5, plus 1 is 6. So, we're hoping that the other cross product will equal 60. What is it? It is 2 1/3 times 25 5/7. In order to do multiplication to these two mixed numbers, I need to write them as improper fractions. 3 times 2 is 6, plus 1 is 7. So the first one is 7/3. The second one is going to be some number of sevenths, but I'm not sure what. 25, 7 times. 7 times 5 is 35. 7 times 2 is 14, 17. And then we'll add in the 5, and I'll get 180. So let's see. When I multiply these, certainly my 7s are going to cancel. I will have 180 thirds. I'm really not sure whether 3 goes into 180 or not off the top of my head, but I'm going to want a mixed number regardless. So I'm going to just divide 3 into 180. 3 goes into 18, oh, exactly 6 times. 3 goes into 0, 0 times. So in fact, we do get exactly 60. Is the proportion true? Yes, the proportion is true. All right, just a quick remark on cross-multiplying. There is one time ever in your life at all that you will want to cross-multiply, and that is only when you are checking whether a proportion is true or trying to find a number that makes it true. Also, we will never, ever, under any circumstances ever, look at the ratio of the cross products. Right? The only thing we will ever do with the cross products is try to see if they're equal. So, never look at the ratio of the cross products. Only write down the cross products and see if they're equal. You should cross multiply only when you're working with a proportion. When you circle the cross products, this symbol inside where your circles cross, this better be an equals sign. If this is not an equals sign, cross multiplying was not what you wanted.